3, 2, 1. Welcome back. This is session 3 of QGIS Open Day, 29th of January 2021, and we are joined by Saber Razmjooei. How did I do pronouncing your surname, Saber?
Razmjooei.
Razmjooei. Martin Dobas and Nyall Dawson, all celebrity QGIS developers and community members, and I'm really excited to be joining this session because they're going to be showing us some amazing things coming in QGIS 3.18 relating to point cloud support, which is a new feature or new set of features for QGIS. So I'm just going to check if everybody can hear us in the stream. Can you just in the chat room just confirm if you can hear me okay? Long, tense silence while we wait to see. Okay, Ismail says we're all good. Okay, great. So we're going to just dive right in. We'll start with Saber, who's going to give us a bit of an overview of 3D in QGIS, and then jump over to Martin, who's going to show us some flashy 3D graphics, and then Niall's going to show us the 2D point cloud support as well. So over to you, Saber.
Hello, everyone. Yeah, in 2017, we started QGIS 3D, and more and more there were features added to it over time. And one of the main missing components was point cloud. There were already several data providers and visualization tools around point cloud, but we felt QGIS will be a very good way of integrating point cloud with the rest of your GIS data. As I said, there was one proprietary closed source tool for handling point cloud in QGIS, but we felt it's better to have it as another data provider and visualization tool. And we ran a crowdfunding campaign in collaboration with North Road, Nyall, and Point Cloud, Howard. And it was probably, I might be wrong, but it was one of the biggest crowdfunding campaigns in QGIS. And it didn't take long at all to get the funds and get going. And since then, we have added quite a lot of features. 2D visual first PDO integration for reading and reading data, and then visualization in 2D, 3D. There are still quite a lot of features missing, like processing tools and better visualization, which we are aiming to add in 3.20 and 3.22. If we can get enough funds for that, but yeah, Martin will be able to demo what we have so far now, and you'll see the progress, and hopefully we can try it and give us feedback and file tickets, I'm sure, QGIS in the next couple of months. Over to you, Martin.
All right, cool. Thanks for the intro, Saber. So yeah, we were really very pleasantly surprised how well the crowdfunding went, and it just has shown that there is really a lot of interest in point clouds in QGIS. So maybe we could do just like a very quick intro to point clouds, like what they are and why you maybe would want to have them in QGIS as well, and like what's so special about them. So let me just start sharing my screen. Hopefully you can see my screen now. So I don't really have like a slide deck, but just a bunch of pictures in the browser. So this is an example of simple point cloud. So what you are really looking at is like a bunch of points in the 3D space, and that's essentially what it is. So you may wonder, like, why would we need some special support for such a thing? That you can just simply have a vector layer with point geometry with z coordinates as well, and just use that. That is true only to a part. It is possible, but the issue is that the vector layers, they were never meant to be used with the amount of points that we normally see with point clouds. So while I can say that generally with vector layers, one deals with maybe like thousands or maybe up to like millions of features. Here with point clouds, like the million data sets with a million points, that's like very, very small data sets. And generally we are talking about like many millions or even billions or more. To just give you a rough idea, this is a website with USGS data from the LiDAR survey from US. And so you can see here that there is like maybe half of the area of US covered. And this is the number of points in the whole data set. So that's actually not even billions, but like 26 trillions of points. So that just to give you a rough idea, like how huge these data sets really are. So the point cloud support for QGIS is really to address this sheer amount of data to handle that efficiently. And now, like, how do we even get a hold of some point cloud data? So one, like the most common source of point cloud data probably is LiDAR. And the idea is that you have a laser scanner mounted typically on an airplane, or it could be also terrestrial or mounted on a car, and it shoots laser beams and looks at the returns from that, and processes that into the like a big cloud of points in 3D. So that's the one source. Here's another image, like how does it work then in practice, that as the airplane is flying, it's covering maybe some like 1 kilometer range or lower, like one swath of the laser returns. And as there is a laser beam being shot towards the Earth, by the time the beam hits Earth, it's maybe size of like a plate, like 20 centimeters or so. And sometimes you get just like one return and you get 1 point, but sometimes in areas where you have vegetation or so, the response is more complicated, and then software usually picks several returns which get reflected from like branches and leaves and so on. So yeah, that's LiDAR. That's one big source of data, and the other one is to use photogrammetry, and that's using the methods of so-called structure for motion, where you would take a camera, take pictures of some object, and then use some computer software to actually figure out what are the pairs of points that are matching to each other in different pictures, and based on that, it's possible to create point clouds. Right. So with this short introduction to point clouds in general, we can have a look at how things work in QGIS. So I have a QGIS open here. Point cloud data, they are usually distributed in the LAS file format, and it's a binary format that contains all the points. And there are two variants. So one is the basic LIS, let's say basic uncompressed, and then there is compressed, which is called LAZ. There is quite a difference in the size, so it's usually recommended to use the compressed one. You can see this same data set compressed is about 80 megabytes. The uncompressed one is about nearly 500 megabytes. So, and if I open my favorite test data set, so I just take this LAZ file and drag and drop it to QGIS, and it opens. So you can either do it with this drag and drop, or of course here in the browser, that's the other way how you can open it. It's here, and this is, I believe, this first one, which I can drop here. Or for those who prefer to use the data source manager, you can open the dialog, and here with point cloud you can specify the path to the LAZ file and load it. Cool. So now the point cloud is loaded. It automatically got some default styling. We will talk about the stylings in a bit. And so just like any ordinary layer, you can open the properties and see like the path, extent, point count, for example. So here you can see it's roughly over 3 million points, and so on. Some the list of the attributes that are associated with this data set. So you can see here that we have the XYZ coordinates plus some more attributes. So whether you have these attributes or not, that really depends also, like, based on which kind of method you have the data. So if you have the data from LiDAR, you would have these attributes like return number, number of returns, intensity, and so on. If your data are coming from some photogrammetric methods, then there is no sense of talking about return numbers, but you would get some other attributes like red, green, and blue components of the color that the point had in the original pictures. Cool. So and now when the data set is loaded, you can just work with it as like with any other layer. As you would expect, it should open match correctly with any other maps that you may want to use as a background. If not, it's just a matter of setting right coordinate system. By the way, I would maybe stop for a little bit with coordinate systems. So point clouds, they should also have the CRS assigned to them, but very often that's not the case. Or also when you have the CRS assigned, it may not be recognized by QGIS, and that's because some of these coordinate reference systems, they are 3D, which QGIS doesn't properly support yet, and it may support them at some point later. Anyway, so you can move, zoom in, zoom out. You can use the identify features tool to get more information. So if I zoom in more, I can pick some point, and I get the XYZ coordinates, the classification, the intensity of the reflection, that it's the return number 1 out of 1, and so on. Here you can probably also see that all the points, this is the LiDAR data set, that the points are arranged in like lines based on how the laser was getting shot towards the ground. So yeah, and this is the typical property. You can see that if you zoom out from the point cloud data set a bit, it looks like you are looking at some homogeneous polygon data, but actually as soon as you zoom in a bit closer, they suddenly start to fall apart into points. Right. Nyall, would you like to take it from here and talk about the 2D rendering a bit more?
Maybe we could just quickly field a few questions before we switch over to Nyall as well.
Yeah, sure.
That's okay. So the first one was from Jacob Chariton, who asks, is GPU acceleration supported in point cloud rendering?
So for 2D rendering, it's not. For 3D rendering, just like for everything else, we use the GPU for rendering. We will get to 3D rendering later.
Mm-hmm. Yeah, and then
I'd say with 3D rendering, it's a necessity. So we've had a few people try it without 3D acceleration, just using like their CPU and the software 3D driver, and the results aren't great. You need a proper 3D driver installed, which most people have. It's mostly just kind of Linux users using some weird esoteric setup that don't, or a virtual machine.
Yep.
Great. And then there was a question about which version of QGIS you're using, because the QGIS Nightly on Windows does not support point clouds yet. So maybe you could just explain about the packaging issues there.
Yeah, so we are aware of that. So I'm using like the development version of QGIS 3.18 on Linux. And yes, on Windows, we still don't have the Plural Library, which is a dependency of QGIS now, packaged. So that's something that's being worked on, I believe, by Jürgen. And yeah, hopefully sometime very soon, the point cloud support will be available also in the nightly builds of OSGeo4W.
Okay, thank you. And then there was a question from Jacob Chariton again. Are attributes like radial reflectance, normalized height, etc. of point clouds supported, or are only regular LAS specification compliant point clouds?
Yeah, I believe any attributes should be recognized. So yeah, even if people are having some custom attributes, they should appear here in the list of attributes. But I have to say as well, I haven't really tried that myself.
Thank you. And then there was from Justin Saunders, are there any classification tools?
Not integrated in QGIS right now, but there is Plural Library, which maybe I should have talked about it a bit more also before. So this is the library, just like Google or GDAL is the library we use for handling raster and vector data. We use Plural or PDAL for handling point clouds data. So here you can see in the documentation it has quite a long list of various different formats that the library supports. That said, in this initial release of QGIS, we are right now only supporting the LAS file format, like LAS and LAZ, the compressed one. And this is like the industry standard, I would say. It's kind of the shapefile of point clouds. And yeah, so eventually we would like to make this a bit more generic so that we would support also like any other drivers that are compiled in Plural, but that's not yet the case. Yeah. And yeah, sorry.
Okay, and then John Donovan wants to know, how does it cope with huge point clouds, like billions of points?
Yeah, so that should be working as well. There will be probably some problems with huge point clouds, but yeah, the way the rendering works right now is that we are not like if you look from far away, we are not trying to render all the points, so we wouldn't be rendering billion points at once. What we instead do is that we kind of index all the points that we get as the input and prepare them into a data structure which allows us to do the rendering efficiently. So at this point, like we are maybe rendering some 50,000 points or so, and as we are going deeper, we know that like we need more details, and we render just like small area, but with more points. Maybe here I should also say like now, let me close this and reopen the file. When I opened the file, it opened immediately. But that is because this point clouds dataset is already indexed. The index, the QGIS will create a new subdirectory where is the source file called ept underscore and like the name of the file. And this directory has like all these data we need inside. So in case I would delete this directory, what happens that now if I open the LAZ file, I don't get anything shown, only this extent. And here below, you can see that the data set is getting indexed. Now it reached 100%, and I can view it. So, and the index directory is here again. Compared to spatial index that people may know from vector data, this is actually a full copy of the original file. So if this file was like 15 megabytes big, this one, the index is also like similar size. It's even slightly larger. And so from the time that we have the data set indexed, we actually like completely forget about this original file and just use the data we have here. The reason is mainly that in these source files, the LIS, LIZ, it's like a big soup of points. So we don't know anything about the organization. And if we were trying to render them directly as they are, we would really need to like go through all the millions of points in the data set. So with this indexing tool, we should in theory be also able to handle large data sets, like even like billions of points. But yeah, there could be still maybe some optimizations necessary on the QGIS viewing code to make it be really smooth and seamless.
And I have to ask, even though nobody asked, because I'm sure one person out there in the world is like me wondering, could you load the 27 trillion points from the USA all in one go?
In theory, yes, and we are nearly there. Here, there are also links with this EPT acronym, and if I click on one, I get this JSON file, and that JSON file is actually exactly the same format as we use here. This is the kind of format or standard that EPT format that the friends at Hobu have created, and so it's like entwine point tile format, and it says like how the data should be stored. So this USGS dataset, so where was it? It's where did I leave it? Anyway, it's already prepared in this way, but there it is. But we do not yet support remote data sets. But hopefully this should be also ready maybe in the next release, like 3.20 or so, because I think there is a lot of interest that someone who has these large data sets, it makes sense to pre-process them just once and then let the users to use this indexed data.
Wow, fantastic. Just 3 more quick questions, then we'll move on. So quickly from Lena Fisher, she wants to know, in 3D, will there be IDOM lighting support? I guess Nyall can show us. I'll talk about that.
Yes. IDOM, or sorry, you meant in 2D? Or?
In 3D.
Yeah, in 3D, it is there. Yeah, we will demo it. Okay. Maybe at some point in 2D as well.
Okay. And then Chaplin asks, maybe I missed it, but is the RGB info ingested as well?
Yes, it is. In case the dataset has it, yeah, I think Nyall will talk about it more.
Okay. And then just quick last one, will the profile tool work with the point cloud?
That's also something on the wish list. So not yet, but hopefully, if everything goes well, then we should have also integrated profile tool in QGIS that would also be able to handle point clouds.
Fantastic. Okay, I'll stop taking questions now because I know you've got lots more things to show us. If people are watching, you feel free to keep asking questions. I'll collect them up and we'll do another round of questions at the end if we have time.
Cool. So over to you, Nyall.
Okay, I'm just looking for the share. Oh, here we go. Share. Okay. So I've just loaded in one of the point clouds from close to the area where I live, and I'm just going to run through some of the 2D styling options that we've got for point clouds. So just like any layer type in QGIS, you can set up the styling either in the layer properties under symbology. We've got all these options in here, but the easier way to do it is with the layer styling panel, and point clouds work seamlessly with this nice docked layer styling thing. So if I load in a point cloud immediately, so I'm just going to grab this one here, load this in. There's certain logic that is set up in QGIS about how to style that point cloud initially. So one thing we do is we look at the attributes that are inside that point cloud. So this particular one here, if I have a look, it has the XYZ. It has a classification. It doesn't have any of the RGB values in there. So this one was taken from an aerial LiDAR survey, and it doesn't have that RGB information. So when we're loading it into QGIS, it defaults to the classified view. So basically, the logic looks a bit like this. It's if there's RGB values intact, then that's how we'll style it initially. If not, we look and see if there's a classification, and if so, that's the way it gets styled by default. Otherwise, we fall back to styling it by the Z value, so like a graduated symbology by the elevation. But again, in this case, this one here has a classification attribute, and it's applied this kind of default color scheme where we can see that all these different points have got a classification that someone has processed this data set up and applied for them. And if I look at any of them using my identify tool, we should see, so I grab this one here. So this classification for this point is a medium vegetation. So it's basically styling it by that classification that's been calculated for each of the points there. I should start. Actually, I should have said at the very start. This is a kind of development debug build of QGIS. And the rendering of point clouds is quite a bit slower in this one than you'll actually see in the final release, because there's certain optimizations that get applied in that final release which aren't intact on this one. So you can kind of see there's a little bit of a delay when I move around. On the actual release builds, it's much faster, much smoother. So this is kind of worst case scenario in terms of speed. But anyway, with our classification renderer here, we can do things like switching off some of these classifications. So if I decide, I don't want to see the vegetation, I want to see the ground level points, I can go through here and I can switch off some of these ones. So now I'm only seeing, for instance, the ground and the building points and water and some other scattering of different classifications we've got there. But now I can actually start to see a bit more of the structure that's in this area. And actually this, if I find it, where is it sitting? Down here somewhere. This is actually a theme park. So it's we can see there's a water slide here, and there's some other funny rides there and stuff around there. But anyway, So just like a normal vector categorized renderer, we can switch on those off, and we can also go in here and we can change the styling. If I don't like the color scheme, I can tweak my colors here a little bit and refine them however I want. We've also got the options here of doing things like we can change the actual size of the points. So I could change my size to 2 millimeters, round points maybe, just to change how that layer is appearing. And actually a nice thing you can do here, because if I zoom in close enough to this point cloud, we'll start to get to a level where we actually can see the spacing between these points. But because QGIS has quite rich symbology support for 2D, I could set this up and I could actually say, give my points a size of 2 millimeters, or I could say, let's maybe make this say, 0.2 map units. So in this case, meters, so 20 centimeters. And so as I zoom in, the points will actually get bigger. And I could even go in here and I could refine this and say minimum size of the points should be 2 millimeters, but if I get in closer, make them get bigger. So you've got all these kind of really nice, rich symbology options that you get throughout all of QGIS, really. And actually, we also see things like we can control the whole layer opacity there, and the blending mode. So you can have your point clouds with a certain blending mode interacting with other layers in your project. So that's the classified renderer. So we've got the classified renderer there. We've got a couple of other renderers here. The simplest one, I guess, is this extent only renderer, where all we see is the actual outline of where that point cloud sits. Maybe I'll load in a OpenStreetMap layer here just to give it some context. So it basically just shows you the boundary. So that could be handy if you had, a whole bunch of point cloud layers loaded into your project, and you don't want to actually view them in this particular scale range or something. All you want to see is the boundary of them. It's kind of like a catalog. This extent only renderer lets you do that. And again, you can get in there and fudge with a symbol if you want. Okay, so the next one we've got, there's a RGB renderer, which I'll come back to in a minute because again, this one doesn't have red, green, or blue attributes. So for a point cloud like this, I guess it's only kind of useful if you wanted to set up some sort of false color visualization, but I'm not sure how often people would actually want to do that. So we can look at this one. This is attribute by ramp is another option we have, where we get to pick one of these attributes, say the Z value. And just like a kind of raster pseudo color renderer, this applies a color ramp to the values in the points of the attribute I've selected. So in this case, we're seeing the points being shaded between 3 meters high at a dark red to 115 meters high at that kind of blue color. And we've got all the same kind of styling options as we have for raster layers here. So you can kind of go in here, you can tweak how the ranges are calculated, the color ramps and all that kind of stuff. So lots of different options there. And of course, I'm not restricted to doing that just with the Z value. If I want, I could do it by, say, the number of returns. So now the values are going between 1 and 7, and I'd kind of expect that the vegetated areas, I'd be getting more returns, and we could use this as a way of identifying different features that are present in that point cloud. Let me just unload this one for a second. I'm going to load in a different point cloud here. So this next point cloud I'm going to load in, this was created using Photogrammetry. And this one, if I have a look, actually has so this one has those red, green, and blue attributes in there. And if I look at my statistics tab, for instance, here, you can also see that the red, green, and blue values in this point cloud vary somewhere between 3 and 255. Here's the mean, here's the standard deviation, etc. But when I've loaded this one in, QGIS has seen it's got those red, green, and blue attributes, and it's defaulted again to the RGB renderer, which actually lets us see the color information for those points. And that's a good way to actually see that kind of aerial view, I guess, of the point cloud if you've got that information present. And again, we've got all these options in here that we see in the kind of standard QGIS raster RGB renderer, where we can do things like we can apply a stretch to these values. For instance, if I want to see, boost up the contrast of my red or something like that, we've got all these different options in here to mess around with those values again. I guess the last thing I'd like to show on 2D point clouds in QGIS is probably not unexpectedly, if I'm working in a print layout, and I put a map in there, my point clouds show for just like any other layer that we've got in a vector layer or raster layer. Will show nicely and will output nicely and will play nicely with print layouts and high resolution exports. I guess back over to you, Martin.
All right, cool. Yeah, now I guess let me try to dive into the 3D stuff. So
maybe just before you go to there, Martin, we could just take a few more questions from Nyall, if that's okay.
Yeah. Mm-hmm.
So there was one asking about whether it's possible to import Sonar data, or because there's already a plugin for PDAL for that. Do you guys know if that's possible?
So in our initial implementation, so that's kind of round one of the point cloud ongoing project, we're only allowing the LAS and the LAZ file formats, but definitely in future stages we'll explore all those other formats that PDAL can read.
Thank you. And then Lena asked if there are standard color ramps for point clouds.
Do you mean like for the classification? Not as far as I'm aware. And actually, if I can just show my screen again, this classification that we're using here, or this default kind of this default coloring, it's actually supposed to be a placeholder at the moment. It was added just as a quick and dirty, we've got to get some colors in there. And I was hoping someone would actually come in and refine them and make them nicer, because they're actually just taken from old school video games, and it's the CGA color palette. If you look carefully, that's why they're kind of not great. So if you feel like volunteering on the project and you've got better ideas for the default color scheme for these classifications, definitely send them through.
Great. And then a quick last one: can you export as a raster with a defined pixel resolution?
Again, there's probably not the proper way of doing that yet in this part one, but there's nothing stopping you from basically exporting this map. So I could export this map to an image, and it's going to be geo-referenced, and I could bump up the resolution there. So yeah, I could just grab this, get the extent of that layer, crank that right up and turn it into a raster that way.
And sorry, a quick last one snuck in by Leo. Can you use the GPS time in the symbology?
You can, if it's there.
Yeah, I guess this one doesn't have GPS time. Oh no, sorry, I'd have to do it in this one. GPS time. Yeah, but I'm not sure how you'd expect that to look, but it is somewhat possible, I guess.
Yeah, it could be that there is just like few values that are off, and that's why like the whole min-max range is a bit wrong. maybe if you try fiddling with the max value, we would see something.
All right, maybe that's one for.
Anyway, it should be possible. I just don't know how useful the values are in this particular data set.
And maybe I can ask then if you've got time in there, but that's an epoch time, is it? It's not like a date time field. You can use the temporal framework.
Yeah. Look, I pondered this for a couple of minutes in my head, and I wasn't really sure if there was a strong use case for for kind of visualizing point clouds using that.
That you can watch how the plane flew over or something like that as it paints the dots onto the map or something. Yeah.
Yeah, maybe there is strong use cases, but I kind of was like, oh, it seems like a bit of a pretty corner case, I guess you'd say. But maybe maybe there's something that I'm missing there.
Okay, thank you for those. I think let's keep moving on because we're going to run out of time otherwise. So we have about 10 minutes left in the session. Martin, if you'd like to show some 3D.
All right. So hopefully there will be not too many crashes. So
sorry, just before you get going, if we do get cut off because the stream cuts off at an hour, just stick around, everybody watching, and I'll reconnect us again. So don't panic. Okay.
All right.
Thanks.
Cool. So yeah, in the layer styling doc, so there is the 2D rendering setup and the 3D rendering setup. And sorry?
Can you share your screen again?
Sorry, I thought I'm sharing it already. Is it better? Can you see the screen?
No, not yet.
Really?
We can still see Nyall's screen.
Okay, maybe just Nyall needs to unshare it.
I already have.
Okay.
Maybe just share and unshare again, or unshare and share, whichever way around.
Have you tried to turn it off and on again?
Reload your browser window and just jump into the chat again.
Yeah. Okay, let me do that. All right, so let me try to share the screen again.
Yep, that's looking good.
Can you see it now? Okay,
yeah.
Cool. So yeah, just like we have the tab for 2D rendering, there is another tab also for configuration of 3D rendering for point clouds. And fortunately, the setup is more or less equivalent. There are just a few differences. So you can also do the classification, styling, attribute by ramp, RGB. There is also option to have just single color rendering for the whole point cloud. Maybe we can start from there. And here, as usual, I will just open the new 3D map view like this, and I get this blue blob. No? Okay, it survived. Cool, so it is 3D, but you can't see much there because it's all blue points. So let me switch to classification, and that's much better. By the way, we are still having this like 2D rendered map underneath. So what I usually do is that I go to 2D settings and change the rendering to extent only. So now I get just this. This is, by the way, like there is a jump here vertically, because I think this is elevation above the sea level. So we are still having some trouble with the navigation when using like the default terrain-based mode. So what I typically suggest to people as a workaround to go to settings and set the elevation of terrain with some offset, I think 200 should be more or less fine. And then the rotation and moving of the canvas will be nicer. So we have the classified rendering. In the same way, I can also do the attribute by ramp. Oops, and yeah, maybe my QGIS has just crashed. So it will take a little while until it gets completely removed and I can start again. Yeah, so the same rendering options. And we can have a look next when I manage to restart QGIS at the shading options. So I will get this one. I can set the attribute by ramp, let's say the Z. Something like this. Okay, new 3D map. Cool. So, and I will also remove the next. Okay. Now, so still. We can't really see that much detail here on our point cloud because we just show a single color for each point. But we have also implemented support for so-called IDOM lighting, and that one greatly improves the way how the rendering is done. Essentially, we figure out what are the differences between the neighboring points and shade them accordingly to get the better 3D feel. And also the points that are next to each other, but there is a big jump in the depth. We create the silhouettes there. So you can see like the black silhouettes. And suddenly when you compare, like here you can barely see anything, and here you get pretty good idea of what are you looking at. There is even possibility to turn on the shadows. So that will give you slightly different results, and this is based on like how you define the light. So you can define the directional light with altitude, azimuth, color, and intensity, and so on. And based on that, you should get so you can see how the roofs are shaded. You can even combine these two together. That's also quite an interesting effect. This is now without shadows. There is a lot of room for both experimentation and also for some improvements there still. What is important to note that there is a new way how to here in camera tab, how to navigate through the through the 3D view. So what we used to have is now called the terrain-based navigation mode, and now there is also the walk mode. So this is very easy to use, that if you just use your mouse to rotate around with left mouse button clicked, and then you can use either your arrow keys to like walk in or back, or if you used to play 3D games, you would know the W, S, A, D keys for that. You can also move the view up and down with Q and E keys. And in this way, it's like much easier to inspect the point cloud in more details. You can also use the mouse wheel that to change the speed of navigation. So here on the top right corner, I would change the speed to be slower, and now like the step is slow if I make it big, so it's easy to do then like small steps or big steps. Yeah, so this should help you with navigation quite a lot. And just like with 2D, you can also set the size of the points. So if you are getting closer to them, you can make them bigger. Play with the maximum screen space errors. If you want not to use that much graphics power. Okay, so, and for those interested, there's also this option like show bounding boxes, which is like a way how to see under the hood, like what is going on there. And you can see that as we go further away, that we remove the amount of detail, and as I get closer, there are like more detailed cubes showing up. Cool. Have I forgotten anything important?
I don't know, but we're about to run out of time, so maybe it's a good place to wrap up.
And I'll quickly just show on the right-hand side there that elevation tab as well, where you can offset the point cloud if you want.
Oh, yeah. So there is also an option to modify the elevation of the whole data set. Oops, I think I have put it above like this. So I took it like to 200 meters below. I can even change the scale to make everything extended in the Z coordinate. Oh, like this.
We've lost your screen, Martin.
Oh, did you?
Yeah.
I will try to share again.
While you're doing that, maybe just a couple of quick yes/no answers. Lena asked, "Can you add a path for walkthrough?"
Sorry, I didn't hear that properly.
Lena asked, "Can you add a path for doing a walkthrough?"
Actually, you can, but
Just
I think
using the
my
normal
computer.
through.
Yeah, I
flying
might. While Martin's having issues, so you can't say take a line layer and turn that into a path, but you can set up predefined places in the 3D view. So you can move the camera to a certain spot and say, "Here's my first view at this time." Move it to the next spot and say, "Here's my next keyframe where the camera should move to," and you can set up your animation that way. and make you kind of fly through, follow a path like that.
Okay, thank you very much. I think we're going to have to stop there because we've got the next talk starting in a few minutes. It's been awesome to watch, and I've obviously been